Thank you, Ben, for reminding me to record this. I will start over real quick. So we are getting ready for the V012 release. This is largely focused around BLS, but has a number of minor networking changes. Some which would be considered backwards incompatible, but primarily a lot of this stuff is kind of on the edge cases regardless. But first we'll do just quick, this is the quick opening. Then David from Protocol Labs is here. Sorry, someone just messaged me because I changed the password, which I said a second ago was a terrible idea. Okay, sorry about that. I'm just gonna tell everyone the password. Okay, but Dave from Protocol Labs is here. He has, we've been looking at the new Gossip Sub V11 spec, and they've done a bunch of really awesome testing, attack scenario testing. So we can talk a little bit about that and a little bit about maybe open up for questions if there are any, and also talk about implementation plans. Lakshman is here, who's been working on network testing. He has an update on stethoscope. And then, as I said, we will get into the general spec discussion. We have a number of items to hit there, then open discussion. Cool. Any other quick updates that people want to do? Like, for example, if noise was not completed in your implementation last time we talked, but it's worth saying, or anything like that. Any quick updates?
In Teco, noise was not enabled for sync. Now it's enabled for sync. Now we're working on enabling it for gossip.
Nice. And what's the distinction in enabling it between the two? Is it just a matter of turning it on and off, or is there something more complicated there?
Jem, are you thinking about Snappy rather than noise?
Oh, yes, yeah.
Yeah, because there's the blocks and the frames format, so there's slightly different. Gotcha. Cool.
Yeah, I think our noise implementation is all good now.
Excellent.
Did you just say there are different formats for gossip versus RPC requests?
Yes. So gossip uses block format.
Okay.
And RPC request uses the frames, which is a little bit better for streaming.
Okay, so I think we need to switch to the block format. Okay, good to know.
Yeah, that was a clarification made in 11.1. It was not clearly specified prior to that.
So that explains why we weren't seeing gossip, which is helpful.
Yep. Any other updates? Cool. Great. So David is here. David, you're welcome to share anything on the V11 side that you would like. And we can also open up for questions. And then from there, talk a little bit about if anyone's had a chance to dig into this, the estimated timelines on it. Maybe one thing, David, is you could help us understand the complexity of the upgrade in terms of dev time, in terms of how deep the changes go.
Gotcha. Thank you. Yeah, absolutely. And so kind of like, just because we haven't shared an update in a while. So since the last update, the Gossip Sub team has reached a very important milestone that has been a result of like a multiple stage journey. And just like to quickly recap for everyone. So we went from early March, like doing a lot of protocol design and implementation work. And this is all public, like, so it's in our GitHub. You can like check it out. Internally, we did a big literature review, and like we enumerated the attack vectors that we could identify for a network like Gossip Sub, but also primarily for our main users, so Filecoin and Ethereum. So we were like targeting those type of networks primarily. we designed a series of mitigations, which essentially is the Gossip Sub v1.1. So you can find on the spec all these mitigations that we have designed, and this is also public, available with the entire community. And from there, we created an evaluation plan with 11 different attack scenarios that were inspired by the attack vectors that we enumerated. And we used TestGround, our platform for doing distributed testing, to run multiple simulations and see essentially how the implementation would behave. From that work, we generated like a pretty long report, a 60-page evaluation report. We have already shared with some folks here. I'm happy to share with more folks if interested. And we hope to release this report with the entire ecosystem. The good news from the report is, like, from our tests, from our simulations, Gossip Sub v1.1 did improve significantly in comparison with v1.0, from things of like achieving 100% delivery rate even under attack, not seeing delays, higher latencies than 1.6 seconds for the 99 percentile of message sent. And so, of course, like, these numbers can change depending on the size of the network, the number of messages, the number of malicious nodes, but like, we run multiple variations, and we are really happy with the results. What we are doing now, like what is in front of us, is we are working with the list authority that is auditing the protocol and implementation once more. And so far, good news is that they haven't found anything alarming, and they will be sharing the final report from their audit with us on May 13th, so next week. We are also reaching out to our main users to make sure that they update to Gossip Sub v1.1 and see how it works for their implementations, for their deployments. And we are preparing a launch release for the next 15 days. So a Google blog post, notify the community, invite everyone to upgrade, etc. Simultaneously, and this is really interesting, we have integrated Gossip Sub in Project Lotus, which is one of the main Filecoin implementations. And they will be releasing a new testnet next week, so the week of May 11. And we are going to use our attack code and TestGround as the platform to attack that test network. And why this is interesting, because it takes us from simulation to actual real network with real network constraints, conditions, geographic distribution, etc. So we are really looking forward to have this opportunity to see how Gossip Sub behaves on a large setting. And yeah, like, we will share the results as soon as we get any. Yeah, and this is like the update. So a lot of things. Happy to go in more detail on any of them.
Yeah, quick on the last thing you mentioned. What's the process of going from using TestGround as a simulation framework to actually using it to deploy nodes into a real network?
Great question. So TestGround itself, like, we call it a simulation, but it's a simulation using real hardware. So we have a cluster running on Amazon that we can deploy as many machines as we want. So the simulation itself was already mimicking a real network. But now what we can do is spin the malicious actors, so the malicious nodes on TestGround, connect to the real network and attack the network. And like, TestGround enables us to have like presence in the network as any other node would have. So like public IPs, connect to the entire network, run the test as long as we want, etc. And so it's basically pointing our guns instead of like the simulated network to the real network and gather results. And given that we already did all the work to parse the output of the runs and kind of like try to take insights out, we can reuse that work to gather the results we get out of these runs and see if like latencies change, if the message delivery starts failing, etc.
Mm-hmm. And one of the big differences here that you might see, anything application specific that might be affecting messages,
exactly,
like induced latencies from the verifiers and things.
Yeah, exactly. So that's the other thing. In our simulations, we try to mimic both like what Ethereum and Filecoin were doing. And we try to mimic to our best knowledge from the requirements that we gathered. But like it will be definitely more interesting to see how the actual application messages get delivered using this messaging layer, and also to see if like the rest of the operation, like the rest of the operation from Filecoin or Ethereum influences on our expectations in terms of like bandwidth usage, again, latency, performance, etc. We in the report have some recommendations about like what are the type of parameters that adopters should use, and we expect to have an update on those once we run these tests.
Yeah, cool. We'll eagerly be following that progress because similar tests might be appropriate for us as well.
Yeah, absolutely. Yeah, and again, like we have all these test plans in a GitHub repo with test ground version 5, which Raul is releasing today at Ready Layer 1. It makes it very simple to add a test plan, and so you could potentially just like replicate that code and adjust it to test the Ethereum network as well.
Excellent.
Do you have a feel for how easy it would be to plug in other implementations into the testing?
That's a great question. So it's part of the test ground roadmap to support other language implementations. In the end, what test ground is doing is building an implementation in a container and running it in a Kubernetes cluster. But right now, we haven't done tests with other language implementations. The support right now is just for Go. That's how our orchestrator works and our SDK works. We do have that as part of the roadmap. Let us know if you would be interested on using it for that use case, because we can bump that one on the stack to be done sooner.
Sure. So it sounds like as long as I just have a Docker container running the implementation, it should relatively
fit
in.
It's relatively simple because the SDK is just like a synchronization service. So you write your own script as part of the test plan. So you can like write that in your own language. And then you just need a thing that connects to the synchronization service so that you know when to execute parts of the script. Think of it as kind of like a play where there's like multiple acts. And so it uses the synchronization service just to know when to start specific parts. And that is the thing that is right now built in Go and therefore only usable by Go, but like it's not very complex to implement it on other languages. We have done some experiments by compiling it to WASM and like using it from JavaScript. Yeah, more progress on that soon to see how it works.
Perfect. Cheers.
Danny, you had a question that I haven't answered yet, which is kind of like complexity and kind of like the amount of time that it would take for someone to develop Gossip Sub v1.1. So assuming,
and I guess first of all, it's worth noting, I think most people are probably aware that it is backwards compatible. It's
exactly.
Of the protocol, yeah.
Yeah, absolutely. That's also correct. So backwards compatible even to FloodSub. So if you have some clients in a small network using FloodSub, they can still receive messages published in Gossip Sub v1.1. Yeah, so in terms of like implementation effort, we believe like under a week, someone, if they have the Gossip Sub v1.0 implemented, the extensions, the security hardening extensions are not that much work, given that they were already figured out. The PR with the changes to Gossip Sub, which included the extensions plus some other improvements in terms of performance, was 1,700 lines of code. So kind of like a big PR, but also multiple extensions. And you could use the reference implementation, which is pretty well documented, to make it easy to onboard other language implementators to follow it. And also we are super available. Like if you have teams that are going to start implementing it, just like point them at our way and we can establish some sessions to onboard them and answer any questions.
Awesome.
May I ask a question?
Of course.
Absolutely.
What are the key changes in 1.1 that are committing to the security improvements? Could you please just raise them?
Yeah, there are multiple extensions. One of them is peer scoring. So now we have multiple ways to evaluate the contribution from a peer, and those multiple ways have a parameter associated to them. So you can even adjust these parameters to calculate the score of a peer based on your preference. Basically, like you can give the weights to each parameter. Then there are other extensions such as peer exchange on Prune. So before, every time some peer would get disconnected from other peer, you would have to rely on some ambient discovery service in the case of IPFS, it's the DHT. I believe in case of Ethereum is this V5 to find more peers. Right now, the peers help each other to refresh the routing tables by like doing a peer exchange. Other things are, for example, spam protection. So now that we can detect if some node is sending wrong messages, and we can lower the score of that peer. And there are multiple thresholds. And so if the score is positive, we send the gossip and we send the messages. If the score starts dropping below negative, we have multiple thresholds where we stop sending the messages, then we stop sending the gossip, and then at some point we just like drop the peer entirely and add it to the denial list so that we don't rely on that peer anymore. We also added, which is not necessarily a security extension, but it is an extension that can be used as a security hardening feature, which is custom validators. So if your application has some specific logic in which you want to discard peers that are publishing some kind of like wrong information more rapidly, you can add your own custom validator to signal that to Gossip Sub and basically inform the scoring function more precisely. Yeah, like I do invite everyone to read the Gossip Sub 1.1 spec. It's kind of like 5 pages long total, and I believe it's pretty well written and pretty clear. I've also have a talk that I delivered another version yesterday at Ready Layer 1, but I delivered one 3 weeks ago at the matrix.org virtual meetup, where I go through all of these details, which can also be a very good way to onboard everyone, especially the people that will be implementing it.
Okay, thank you. Also have another question. What was the number of peers in the simulation, and what is the number expected in test net?
Well, we basically maxed out test ground. Actually, it was great because we were working very closely with the test ground team to kind of like increase the number. Test ground right now can do between 10,000 and 12,000 peers. And so that's what we used. If we could have done more, we would have, but like test ground is right now scaling up to like support more peers.
Yeah, that's great.
Yeah, I believe like the Ethereum network is around 11,000, right? So it should be mimicking it roughly fairly well.
Yeah, the estimates are pretty widely, but that's kind of agreed upon.
Gotcha.
Great. Any other questions for David? Cool. I don't think it's been stated explicitly, but V1.1, especially after having read the report, is very important and something that I think that we should see before a mainnet launch integrated into our stack, just because it does mitigate so many attacks and does a very good job at that. Obviously, it is backwards compatible, so there's probably some room for negotiation there, but if this isn't on your to-do list, I think it's time to put it on there and start figuring out when we can implement. And like David said, the Protocol Labs team is certainly excited about V1.1 and happy to help.
Yeah, exactly. If you can, we would be happy to take the leadership of collaborating with all the language implementers. If you want to establish a channel between them and us, so that we can onboard them quickly and really help them like test their own implementations, we are more than happy to do that. Yeah, it will serve the entire, it will serve your use case, it will serve the entire network, it will serve every user that is using V1.0.
Do you think there's value in doing a deeper dive and a discussion on this with implementers before they dig in, or maybe just open it up for Q&A as they hit issues?
Well, if their goal, if they are instructed just to implement it, they should be pretty, they should be able to get it done just by reading the spec and reading the reference implementation. But then again, we are happy to.
Let's do that, but we'll open up a channel so that people can ask questions along the way. Because if one person has the question, other people probably will too.
Yeah, And we also have some folks on our team dedicated to documentation, so we can like even use those questions to improve the docs for others.
Great.
Does the Go implementation have any unit tests or a
Yeah.
series of tests to?
Yeah, it has unit tests, and I believe the code coverage right now is 82%. Then, in addition, we have all the test plans, which, well, they are even more interesting tests, right? Because they actually spin multiple network sizes.
Okay, so we could duplicate those in other implementations to verify
Exactly.
the implementation. Perfect.
Yeah.
Great. Okay, any other just libp2p questions, conversation before we move on?
I do not have any particular subject, but if someone has a question about another part of the stack, also happy to bring it up.
Yeah, I think we're good.
All right.
Thank you very much, David. Really appreciate it. I'm excited for the report to be published. And if you're interested in reading the report, let us know. It's very fascinating.
Excellent. Thank you so much.
Yeah, thank you. Okay, cool. Moving on. Next, we have Lakshman. Lakshman has been working on stethoscope, which is to common network testing, but he'll give us an update and let us open up for questions after.
Yeah, sure. So I think I presented on this a few meetings ago. Back then, kind of the thinking was like do a bunch of network tests in CI, kind of spin up instances in a CI instance, and kind of pivoted away from that. Realized that's a little ambitious, and trying to create something more like PySpec. So basically, a bunch of YAML-defined networking tests and a test runner. So I'll also link to a specific test definition so people can take a look at what that looks like. And the idea is that I want to create something that's like just pretty simple to run locally that kind of hits most of the table stakes test vectors for networking. So kind of progress, the test runner is complete. Now I'm kind of working on tests. I've written a few. I think the big thing I would ask of this group is GitHub issues with like edge cases for networking that you think should be represented here. Yeah, that's pretty much it. I think the other thing is the way this works is I'll put shell scripts for each client to start up in the clients directory. So I'll probably try to figure most of those out myself, but feel free to add like PRs or tips on how to do that for your client. I've just put Lighthouse so far because I was able to get that set up pretty easily. Yes.
So do you imagine this something ends up being integrated into clients' own CI like they're currently doing with the PySpec tests, or that this lives somewhere else? And what overhead do you think clients are gonna have to do to get this up and running for them?
I think it certainly could be. I'm not really. I think right now it's not stable enough for me to feel, and it's also not like there aren't enough tests for me to feel that it's useful in that respect. But I want it to be kind of simple enough to set up that it doesn't take much effort to integrate it into any other CI system. So like minimal dependencies, stuff like that.
Gotcha.
I would just mention that we have the multinet from the interop event. We have the multinet script repo, which contains basically instructions to launch our clients in script form.
Oh, cool. Where is that?
I don't have the URL in my head, but we'll put it in some. Oh, there we go, Danny. Thanks.
Okay. Cool. That could be a good starting point. Yeah. So the big thing is definitely, I think I'm still sort of like I'm mostly following kind of discussions on eth2 specs and discords to figure out what test cases are, but any kind of like guidance on that through issues would be very helpful.
And what's the range of things that you're looking to test? I know we were talking about like just basic corner cases on some of the things, but are you orchestrating more in-depth tests where you're doing like a bunch of integration work? Are you spinning up multiple nodes in some of these tests, or is it just kind of one-to-one?
So right now I'm just focused on one-to-one. So just kind of valid and edge case messages for each networking domain, and then kind of like features, like making sure that like different compression security things work. Then after that, and I definitely do want to include this as well, is things like multi-client and kind of state propagation, like through the network. So it's all using Rumor to drive the clients. So it's like the programming interface for setting up multi-client stuff is pretty straightforward. So I suspect I'll be able to do some of that as well.
Gotcha. Cool. And on the Lighthouse stuff, you're able to like run these handful of standard tests and show conformance? Yeah, my I think 2 of the 3 tests are working as I expect them to right now. But yeah, that's the idea. Cool. Any other questions for Lakshman? Great. Well, thank you. Appreciate the update. Yep. And this stuff's super valuable. Appreciate it. Okay. Now for the fun stuff. Spec discussion. So I dropped a PR yesterday and on Beacon State sync over P2P. And funny enough, prior to it, kind of considered it a no-brainer, you know, something that we'd certainly want, but have gotten some interesting and valuable pushback on that being a no-brainer. It's like on it was a no-brainer to me because the state is small and bounded, but maybe it's not a no-brainer because the state is small and bounded. You can easily get it from other places. Yeah, I quickly looked at some of the comments this morning. Does anybody have particular things they want to bring up on this? I guess the takeaway is I'm not rushing to put it in right now, but we certainly we should probably come up with standards and document the UX of how you get the state if we're not going to have it available over P2P, and ensure that like all of the cases that we want someone to be able to get the state safely are accounted for. But yeah, Jem, you had something?
I was just gonna like state that this could be like a nice option to have, but I think at the end of the day, we want to keep giving the option to like some nodes to be fully lightweight, that like they don't need to like carry any state at all. So like requiring this would like get rid of that possibility, which is not the best in my opinion.
Yeah, and once you make it optional, you also make it more difficult to rely upon. But also, I will say I'm planning on having a conversation probably with Piper later today. I understand the state sync issues in eth1, and I think a lot of that is because it's very large, but they're also working their asses off to try to remove state sync from the base protocol and from something that must be supported. So there's some good things to probably learn and follow from there. But yeah, I guess the idea of having something that can immediately prune after finalized is very appealing.
It is.
Yeah, I guess it brings up a little bit the question of optionality in general. I mean, if I'm building a listening only client that, like, I don't know, a block store or something that only listens to gossip, or a network, sort of a network explorer or whatever it might be, and I don't support fetching blocks even. I just connect, I connect to the gossip network. How do we deal with that? Like, do we want to allow nodes like that in the network at all? We want to take a stance in that, or leave that up to users, or what do we do? It's a little bit an analogous situation, like to optional state downloading. Like,
yeah, we don't necessarily, correct me if I'm wrong, but in the P2P spec, we don't necessarily say that everything's required functionality. We say what you must do if you're serving such a request. But then at the same time, we don't have anything in the ENR or non-existent topics to try to filter peers by capability, which we had previously discussed. I still do like the idea of potentially integrating a Bloom filter into the ENR for specific protocol capabilities, which might aid this a bit. Go on.
yeah, indeed, we don't say anything. Like, we allow peers to do what they want, which I guess makes some kind of sense, because that's why we chose libp2p, so that we can sort of gracefully upgrade the protocol bit by bit, and then meaningfully continue to operate as much as possible.
Yeah, but we don't necessarily say if someone should support block sync, and thus we don't say if you can, if you should drop a peer or descore a peer if they don't support block sync and things like that. So you're right, this is a bit of a broader conversation.
I have like a more general question, which does relate to this state sync. For example, we have downloaded the state. How do we get sure about whether it's canonical or not? Do we want to download and verify the link, the chain segment, like starting from weak subjectivity block?
Right. So
the state
within some period, the nebulous weak subjectivity period, call it 3 weeks for conversation right now. The idea would be I get a checkpoint out of band, or I just get a state out of band that I trust. For example, I might query some endpoint on 3 different client websites, see that there's a similar checkpoint at an epoch, and now I'm like, okay, I'm happy with that checkpoint. Or client A releases the checkpoint or the entire checkpointed state every release every 2 weeks, and I trust the client and their processes. So there's a point of trust there to get that checkpoint being an epoch and a root at the minimum, and at which point, once you've downloaded the state, you can verify it against that root. But there's kind of a UX issue in that process of where do I get it, how do I get it, who do I get it from, which is also kind of part of this conversation. And there's not a 100% right answer. I like the idea of there's a lot of methods there. I kind of like the idea of clients releasing it, but then it puts some sort of like implicit burden on clients. I also like the idea of someone making some Twitter bot that just releases it every day, and just there being many sources. And for the command line interface to be rich such that I can specify a state and or a checkpoint, so that even if there is some sort of default, I can override, because that's kind of my the whole point of this. Yeah, which certainly opens up the question if there's some sort of contentious fork, what is released and how it's released.
So the general strategy is to download the state at the weak subjectivity period boundary, which is like 3 weeks or whatever.
Within that period, it could be 5 minutes old. It could be 16 minutes old, or it could be 3 weeks old. But something within that period, you show up with a state, and then from somewhere, presumably, you have a checkpoint. You get the state from somewhere. one method proposed was from the P2P layer. Set that aside for now. But you show up, you have a state, and then you block sync from there. Yeah.
Okay, I see. Okay, thank you.
It's similar to like I turned off my computer for a week, and I know that the last finalized state is still safe within the week subjectivity period, and I block sync from there. You know, it's a similar UX, or it's not, that's not the exact same, but it's a similar experience of like grabbing a state from somewhere and syncing from that.
Why so short? I mean, all right, 3 weeks. It used to be 4 months. Then
it depends on the. So I threw that number out there. It's defined by the churn in the validator set. I believe the entire validator set can theoretically churn when there's 300,000 validators, like fully turn over in like 9 months. But it could turn over 1/3, which is like the minimum for some sort of like coordinated attack on this, in 3 months. But at lower validator counts, that number is not as strict. So it's actually dynamic. So one, we should define what that number is, and two, work from there. Sorry, Zari.
I was saying that in one of the first work group meetings we had on Sync, we had this idea that the initial state, the weeks of subjectivity, this old state that you need for the weeks subjectivity period, could be signed by multiple parties, such as the Ethereum Foundation, a bunch of clients, and so on. And this way, the user can be presented with some UI that gives them a bit stronger guarantee that this is a genuine state. And then the idea was that once you have this very old state, you can use the light client sync algorithm to get to the recent root hash. And maybe then you can ask the network to download the entire recent state using the peer-to-peer protocols.
Yeah. I mean, and I think we accomplished some of that by figuring out a standard way to bake it into releases or have it as some component in repos signed. It is certainly viable to light client sync to some trusted root near the head and then download the entire state. Obviously, asking for portions of the state via a light client protocol will probably be a thing, but not everyone will be serving the light client protocol. But that's a viable path, assuming there's a light client protocol there.
and then another thing is that like you have a state, but you actually need a block as well, right? Because the block points out the state, not the other way around. It's a little interesting crux.
Right. Well, given a state, I know very recent blocks. I see. Well, I can construct, given a state, I can construct the associated block by taking the latest block header and embedding the state root. So
Not
then
the
I
signature though.
Right. But I also have trusted that the state is finalized.
If you trust the state, you can always continue from any snapshot. You just need the next block and it references the state, so you're good.
Right. Yeah. The state transition doesn't even need the pre-block. It's the next block. Yeah, I mean, you certainly trust it. Okay. It seems that the proper path forward here is to write more about document the expected sync scenarios along with potentially resource, not necessarily resource requirements, but like the different types of machines and users that might want to initially sync, and then come up with the ways that they may or may not get the state and or checkpoints, and decide if these we're satisfied without a P2P state sync, and have like a sufficient UX to bootstrap the network.
Maybe before that, we need to define a little bit more strongly the weak subjectivity period thing, because it's a little bit hand wavy. And until then, like, transferring the state is not a problem. That's a simple technical issue. You add a request, there's like
right. The weak subjectivity period just affects the length of that period affects the UX a bit, but it doesn't. Only when you start getting into like sub-week times does it probably affect it, like degrade, actually change the way that you might have to interact with it, other than just timing, in my opinion. But yes, we should define that more clearly.
Yeah, because it's not clear why would you need the states behind the most recently finalized one.
Oh, you don't. You don't. You could get the most recently finalized, but that just changes all the time. So I'm saying there's two scenarios that you need to know you're within the weak subjectivity period. One scenario is I am thinking for the first time, so I want to get something that I know is safe and within that time period. The other is I've turned off my computer, I have something finalized, and I need to know that I can safely sync from that finalized. If I've turned off my computer for too long, then I can't necessarily trust that I can safely sync from that point. So, but again, you can have something very new. I could go get the latest finalized and block sync from there, but the latest finalized is only the latest finalized for so long. And if we're going to rely on some of these social mechanisms, like people cutting into their release, or some sort of parties like eth2 signing one, that kind of stuff, we can't assume that these are necessarily going to be published every moment, although they could be. You know, even if it's daily, that's sufficient to get a recent state and block sync from there.
Yeah, if you're like a week behind the head, but you have some data you've previously synced with, you probably won't any way to download the most recent finalized state. It just will be quicker.
Yeah, you'll just block sync from there. If your latest finalized locally is within the weak subjectivity period, likely you're just going to turn your computer back on, turn your node back on, and it just will sync to the head.
But yeah, block processing could take more time than just downloading the state in this case. So
right. But downloading the state brings in potentially, I mean, you could automatically download the state from some trusted source if that satisfies your security requirements, but it also could potentially be a manual thing.
Yeah, I see. But yeah, that's be great if you just put these requirements. I mean, security. What would be the difference between these two strategies? I mean, some document if it's about to be.
Yeah. I mean, and fundamentally, the difference there is I can sync the network without relying upon a single third party and getting a new state if I'm within that period. So I might as well potentially do that rather than downloading from some random URL or some trusted URL. But there's a trade-off there in time, probably at a certain point. Okay, I'll write more about this so that we can make a better decision on whether P2P is a requisite requirement in this state sync bootstrapping thing. I will say that being able to start your client from a finalized checkpoint and syncing from there, and being able to, and considering like locally what the UX around that is going to look like is going to be important, primarily because these nets are going to get older, and this is going to be something, you know, requisite, and also just makes the UX nicer. Okay, cool. Moving on. Dynamic persistent @net count. Johnny's been doing some investigation on networks, realized that on these small nets, he was only seeing some amount of the attestation subnets being used, which brought up the question of, should we be, for phase 0, randomly subscribing for these persistent subnets? Should we be randomly subscribing to all subnets, or just the subnets that are actually being used at any given time based on the size of the validator set? My stance on this is that what we want to do here is, one, simulate some persistent backbone of subnets to be used, which would happen automatically in phase 1 when you have proposers and persistent committees assigned to different shards. And two, there's probably two things we can optimize for here. One is these persistent nets actually being utilized, which kind of simulates phase 1, or the utilized subnets actually being of an expected size on phase 1. The current optimizes for them being the actual size that you'd expect to see on phase 1. Changing them to what we have in this issue optimizes for all validators actually being a part of them at any given time. I lean towards keeping as is, so that we have subnets of approximate expected size, and not introducing any more complexity, but I'm open for discussion. Johnny, anything I missed there?
No, I think you covered it. So you're saying you want to simulate the conditions of phase 1? Is that what you're, before you make a decision? I kind of missed that.
No, I'm saying that so phase 1, we don't have this notion of subnets not being used, even at low validator counts. We rotate through all of the subnets because the subnets are related to shards, and we rotate through shards. And so there isn't a direct analog here. And so there's two different directions. One would be to, instead of assigning validators to non-used subnets in phase 0, assign them to just the used subnets, at which point you have larger subnetworks than you would expect in phase 1. Whereas, and it becomes easier to find the subnets than it would be in phase 1. Whereas in phase 1, whereas if we keep it the same, you have smaller subnets, but potentially harder to find them, which I think mimics a little bit more what phase 1 would look like. But again, there's not a super clear, it doesn't matter that much here, unless we find an issue with one or the other on some of the networks.
Sorry, Johnny, you said that some of the subnets are really small. Which networks are you looking at?
Oh, so yeah, so basically, like, if the validator counts are small, like, you know, for example, like, you know, just enough to activate Genesis, only like there's really only going to be validators assigned to the first 4 committees, but we're going to have persistent subcommittees all the way up. I mean, we're going to have 64 persistent subcommittees, so 90-something% of them are not really needed. So it's not really going to help, you know, discover these, you know, with discovery. And that's the problem. Does that make sense? So we'll have persistent subcommittees from 0 to 63, but only like validators only assigned to committees from, you know, 0 to 4.
But they all get assigned to a random committee though, right?
Yeah, they all get assigned to a random committee, right? But like, but it's only going to be up 0 to 4. But we're going to have persistent committees that are spanning, you know, 64 subnets. which isn't really needed. It's not really helping discovery in that case.
So just specifically in phase 0, we don't have a notion of shard. Obviously, we have this notion of committee index at each slot, which is always 0 index. So if we only have 4 committees at each slot or 8 committees at each slot, which happens when there's not a ton of validators, then we're mapping these committee indices to attestation subnets. We ultimately are we're not using the subnets greater than the max committee index, but we're assigning for the random persistent committee subscriptions, we're assigning all the way to the max. So there's an idea of, instead of just default assigning to the max, default assign to the range of committee size, of committee index. That makes sense. Sorry.
And so there's a function already in the spec to get the committee size, and then there's concern. Okay, well, what if, you know, what if that amount changes in the amount of time that a persistent committee lasts? Well, there's an easy calculation to kind of add a lead to that calculation, you know, so it's going to be at most like a subnet or 2 extra. And so we could make that calculation dynamic, we could leave it the same, or something else.
And I guess my point is that in phase 1, regardless of whether regardless of the amount of committees per slot, we always use all of the subnets. And so in such a case, if we had 16,000 validators, we would still have to find committee members across all these different AtNets because it rotates through. So my concern would be, if we make it really easy to find attestation subnets right now, we're not actually simulating what the conditions in phase 1 through this mechanism in phase 0.
Okay, I get that. Like it feels like that's not like on a live network. That's not really like the time to like test that theory. Well, I mean, number one, like I don't totally understand why we don't just spread the committee members all the way through all 64 like we do in phase 1. What's the reason for not doing that?
Because we got rid of the notion of shard, and committee index will map to shard.
But like, why don't we make that the same? I mean, can't we change the calculation?
To which attestation subnet? Yes, which would require adding some sort of function which maps to shard. I can think about that. I think that earlier in January, there was a strong desire to remove, because of all the uncertainty in phase 1, remove anything that kind of directly implied to what the shard mechanics were going to be, so that we could have a blank slate to make sure that we can get it right. Adding such a function outside of the state transition spec that just modifies the way that the validators using subnets might be in order.
That's the truest way to really like it. So
Yeah,
your
you're
argument
right,
saying, yeah, that's the truest way to show that it's going to work in phase 1. So I would say, if nothing else, we should, you know, maybe at least consider that.
Yeah. Yeah, you might be right. Okay, I'm taking a note. I will see if that function can be written very simply, which I believe it can, and we can put it up for further discussion. Cool.
Cool.
Thanks, Johnny. Your network experiments have proved very useful.
Stealing all of Adrian's code, so thanks, Adrian.
Making sure it works for me.
Yeah. The next up, another one from Johnny. Adverse effect of sharing peers between testnets and mainnet. We've already seen some cross-pollination between these testnets, which is going to make it difficult to find peers in the DHT with our kind of just search method, our very naive search method with the current state of v5, which is essentially just find peers, see if ENRs match capabilities, connect to peers.
Can we add a custom field to the ENR saying the network, like Topaz network Schlessie?
So we do. The fork ID does filter peers by network. Does filter ENRs by network. So one potential here is to only fill your DHT with such fork IDs, but I'm not equipped with the knowledge to know if this is a good or bad idea yet. So I'm open to ideas.
Mikhail and Dimitri had an interesting little back and forth on the issue. Mikhail, or Dimitri, are you here?
Yeah, I'm here. Not sure about Dimitri. So I just can say that I was like my initial thinking was about the security of the DHT, how like adversary can abuse the DHT and start an Eclipse or a Sybil attack. But during the discussion, I just realized that if we have like a lot of networks in the same DHT, it doesn't add any protection against such kind of attacks. So that's what was my only concern with regard to security.
Mm-hmm.
Yeah, so it's not gonna help against the attacks.
So in that case, you're saying it might be reasonable to only, for the time being, add ENRs into the DHT that satisfy the fork ID.
Yeah, it's probably
not a benefit.
Yeah, it's probably a better idea to use separate DHTs for different networks. If it would work, this protection would work if all the participants that we have in one DHT, for example, be gossiping all the information in the network. So if we have like eth1 and eth2 on the same DHT, it will increase security if eth1 and eth2 nodes were participating in gossiping each other's bits of data. So otherwise, it doesn't work.
Hey,
Yeah, this is all. Sorry. Yeah, this is from my perspective. Probably I'm wrong.
H, you mentioned that it would be an easy config option to only insert peers with a fork ID matching. Can you expand on that a little bit?
Yeah, sure. So when I was talking to Johnny, this was like a kind of an issue that he had. So I think it's easy to do from an implementation perspective. I haven't actually thought about the consequences if we actually wanted to keep this thing going until mainnet. I imagine if we had something like that, we would have to modify the searches as well, because if you're doing like a DHT lookup with another peer, and that peer gives you isn't doing this particular kind of like excluding them from their routing table, and they give you a peer that doesn't have the same fork ID, then you don't want to go and ask that peer to find its other peer. So I imagine we could kind of optimize the searching, so it could be a little bit more involved if we actually want to have this like a persistent feature. I haven't actually thought through the entire consequences of it, but in a short-term thing with all these testnets going, it's pretty easy to add.
Gotcha. Okay, so I see a couple options here. One would be to actually reduce the attestation subnet count on testnets in an effort to be able to find peers more quickly. This is not super satisfying because it doesn't necessarily simulate mainnet conditions. Makes everyone have a lot more of the messages and be easier to kind of do local aggregation. And the other potential path is modifying DISC-V5 to be able to kind of add filter to what you put in your DHT and what you search for. I'm going to follow up with Felix to kind of pick his brain on this, and maybe some others.
I'm sorry, you said attestation subnet count. Did you mean fork digest or fork?
No,
ID?
there's a so there's a constant in the P2P spec where you have attestation subnet count, where you can actually use attestation subnets for, say, multiple shards. So for example, you turn attestation subnet count to 32 instead of 64, then you actually have double up use on some of them. So it would make finding them easier because there'd be more people subscribe to them on a given testnet, but would also at the same time.
The previous issue. Okay, sorry. I'm slow.
No. It's kind of related because it's related to AtNets. If you look at the P2P spec, there's a constant. Here, I'll pull it up.
Yeah. You mod by that number, right?
Yeah. So if you turn that number to 1, then it was going to be probably pretty easy to find peers on the right attestation subnets because you just need to find peers on that testnet in general. If you change it to 2, it's going to be kind of easy to find the peers on the right subnets. So you could reduce that number to be pretty low to be able to find peers more easily of particular capabilities on these testnets, but at the same time, you're then moving these testnets further away from actually being mainnet mimicking.
So one of the main issues we want to do this is because the discovery lookups are slow, right, Johnny? When I was running it, some of the default kind of configurations were giving me, I mean, we have a query timeout, which is about a minute per query. But there's ways you can speed up queries, probably significantly. There's a parallelization, so you can search multiple peers at a time. And the default in the code that I've written has like it tries to do, it sends a UDP if the peer is not live. It tries to do another one and it waits, I think, like 8 seconds or something per peer before it times out. So you can reduce those significantly and not have a second lookup. So you can probably speed up the queries as well, which I'm not sure. I haven't actually played around or experimented with the configuration parameters, but maybe we can speed them up to the extent that we don't really need to modify anything.
Yeah. So that was one thing. It was more just like I noticed it took me by surprise, that it happened so quickly. And then so say I'm on Schlessie and I want to find the other Schlessie nodes. It's a lot more difficult because the DHT is so overwhelmed with Topaz nodes that it's almost, it's like a needle in a haystack in that case. But yeah, you can play with the config parameters. I wondered at some point if we were it was sort of like an abuse of the network.
Yeah, you can figure it that way.
Yeah.
1,000 requests a second or something.
Yeah, so I didn't know if that was exactly appropriate or not. But one thing about at least filter, we talked about is, it's easy to, insert some sort of a custom filter in there to only insert peers that have the same ENR fork ID. And you were saying you haven't thought of the consequences. One thing, is that it would make it pretty obvious. I think we'd start running into some of those issues, some of the consequences of that, just seeing how that plays out if that option was added. But yeah, I think it's a good idea to maybe think about it or ask Felix or you guys to stew on it a little bit. So
yeah, sure. I mean, I can add it in as an optional config and you can have a play with it and see how it goes.
Yeah, cool. Okay, so there's finding a solution to this problem. There's also evaluating whether this is a problem or how much of a problem this is. Okay, we'll keep this issue open. I'll knock on a couple doors and see if we can figure it out. Any other comments on this one? Great. Okay, there's a pending PR from Paul that allows for sending aggregates where an aggregate that does not have an aggregator in them. One of the components of the gossip sub validations on aggregates is that the aggregator is actually included in there. This was originally put in there as a DOS mitigation before there was an outer signature on the aggregate and proof, so that the others could not forge messages without including the actual aggregator. Now that there's the aggregate and proof that actually includes an outer signature from the aggregator, this is not actually a DOS mitigation issue anymore. And Paul believes that, say for example, you have a validator client connected to a beacon node in which a message was published, then the beacon node becomes trash, and halfway through the slot, the validator switches to a new beacon node. Then when the validator attempts to do aggregation and asks the new beacon node for such an aggregate, they might get an aggregate that doesn't actually have the, there's a potential that they get an aggregate to sign that doesn't necessarily have the original aggregator inside of it. This allows for a little bit more optionality in this. It doesn't degrade the DOS protections. It does kind of optimize the spec for implementations, which is not necessarily a bad thing. One thing that Paul noted was potentially you could ask the second beacon node for an aggregate that had 0 participants in it. Or potentially it could return an aggregate with 0 participants, at which point we need to decide how that's actually handled in the gossip. Attestations due to another PR with 0 participants aren't actually valid anymore. So that would need to be probably handled in a way that the beacon node responds with nothing. Anyway, have others looked at this, thought about this? That's the TLDR. It's not essentially the removal of one condition in the aggregate gossip condition. I realize as I was going through that this, if you haven't looked at this issue, it's probably really difficult to weigh in based off what my TLDR. Okay, if you're interested, check out the issue, check out the PR. This is something that we're likely going to decide in the next 48 hours if this goes into V012 or not. It will translate into potentially the removal of a gossip condition and potentially changing how a corner case may or may not have to be dealt with in your validator/beacon architecture. Take a look. Okay, Proto, stricter type-based limits and chunk sizes. Can you take this one?
Yeah, sure. So this is not tool breaking, it's just being stricter about the current limits. Right now there's this global limit of like 2 megabytes, if I remember correctly. We can put limits in place per type. So say status request response is just very small. It should always be very small, nowhere near the 2 megabytes. And there's a lot of different types, and each can have like fine, like much stricter limit. And we can base this on the SSE type information for most of these methods. So we can automate it. You don't have to worry about updating these numbers during when we change the versions. So I wanted some input on what others think about stricter limits, and if anyone has already implemented this. It's like DOS protection for their own client.
And Proto, you did implement this in Rumor, right?
Right. So this is already implemented in Rumor. It's compatible. It's just only when you get a bad message, then you can just shoot it down really quick.
Well, and the nice thing about defining the spec is it is safe to do, and defining the spec makes it explicitly malicious behavior to exceed these values. I guess exceeding these values would be malicious because they'd have to be improperly formatted SSD objects. But so it's already bad behavior. It just makes what is bad behavior more explicit.
Have you got the maximum sizes written down somewhere, Proto?
Sorry, can you repeat that?
Yeah, you said you've implemented it in Rumor. So do you have the maximum sizes for like the status message and blocks and things written down somewhere?
Right. So I computed on the fly. So from all these SSD types, you can just derive it, since all types have a limit, all dynamic types. So for a block, you can just ask the block type, what is the maximum size, what's the minimum size, and use that to put the bounds in place. It's only when we have these crazy types, like the beacon state, that you really have to worry about setting custom bounds. But for all these other types, it can just be derived from the type information.
So this could even translate into a note in the spec. Note, minimum and maximum message sizes can be calculated via their SSD, expected SSD types. Give an example and say messages that exceed or below these limits are invalid. So sizes can be used to invalidate them. Do we need something stronger in the spec than just essentially noting that this capability exists? Because like you said, these messages will be, once you decode them, they will be invalid because they cannot be decoded into the SSD constituent types. And so you just know ahead of time that they're invalid. So it's more of an optimization that can be noted. Right? Or am I missing something?
Yeah, well, you just don't wait until you read all the bytes before even processing. So you don't even buffer like a kilobyte for a status request. Like, no, it's much smaller. So like, it's just push these bounds, these safety checks a little bit closer to the networking layer.
I'm curious about other things. Like now that we have Snappy-like compression bombs and stuff like this, might be interesting to consider the limits from that point of view as well. Like make sure that the limits are applied at the right place.
Right. So in Rumor, I did two things. I multiplied the bound with like 125%, so like the worst case snappy compression, so that I have like.
So the worst case snappy compression is growth, right?
It's just like one, yeah. Well, so this is the absolute worst case, like a quarter extra.
Gotcha.
So you can limit your input into your snappy framed decompressor. So you know you don't read more than you should, but then what you get out of Snappy, what you read, you can also limit those bytes exactly, like based on the length. Like similarly, how you already read up to a certain amount of bytes for your SSD, you can limit it as well.
And then there's one other small detail. We're using a variable length integer for the packet length, or for the whatever SSD length. Technically, protobuf allows overlong encodings. So in theory, you can put a very long one there.
I've thought about this as well. So for 64 bits, you have like a maximum encoding of 10 bytes for the variable length integer. So you can just limit that to 10 bytes. And there's like, you just need that one utility function that reads the unsigned integer from this far int safely and just stops errors when it hits more than 10 bytes.
Yeah, I don't think we specify that though. So like the overlong encodings are kind of like valid by, you know, the variant encoding standards, relevant standards. So you can actually write like 11 byte one if you want to, and some protobuf decoders will decode them.
Sure, we can include this as well. Although I do think most like sane implementations of Snappy, or sorry, of protobuf integers already include this 10 byte limit if you read it as a UN64.
We were fuzzing this like the Snappy implementation today, and actually found a panic in the Snappy library, just FYI. So we've actually checked the lengths across the RPC to make sure that we kind of handle these edge cases.
Okay, so we can add a note about the variable length integer encoding, and we can add a note about the size limits.
I think that that's a good path forward. Adding it as a note, essentially the same behavior is valid or invalid in either case, but the this is a nice optimization that hopefully people end up adding sooner rather than later. I guess the variant is not necessarily true, but it's still probably an attack if somebody's sending you 20 bytes of an integer, 64-bit int.
Oh yes, I'm also worried about things like status requests, having like you're allowed to send many more of these than like say a sync request because they're smaller, or they're supposed to be smaller, and then when they're not, you have a big problem if the implementation handles it incorrectly, at least.
Mm-hmm, mm-hmm. Okay, any follow-up on any more questions or comments on this one? Great. I think we're technically over by 6 minutes. I think we're scheduled for an hour and 15 minutes. But you're all still here. Anything people want to discuss that did not make it on the agenda? Open items, questions for some of your fellow implementers, if you've run into any particular hurdles recently. Cool, smooth sailing. Okay, cool. This was a very productive call. There's a lot of action items for me, but I will be knocking on doors as I need review and some comments on these things. Mikhail, did you have something?
Oh, no, sorry.
Oh, sorry, I saw you unmuted. I'll call on you if you unmute, be careful. So great. I don't know, like normal, I don't know exactly when we'll do another call. When we have enough items that bubble up, we will do one, probably in 3 to 5 weeks. But if there's reason to do one sooner, we'll do it. Okay, cool. Appreciate it. And I'll see y'all at Ethereum tomorrow.
Thanks.
That's it. Thanks, guys.
Thanks, all.
Thanks,
Bye.
Alan. See you next time.
See everyone.
Bye.
Bye.